Hi, my name is Sanchit Setia and I'll be representing Group 85 on behalf of Sony Nugent. Today I'll present with design analysis performance of a walking robot using 4-bar linkages. Let's start with project objective. The objective was to design a robot that can walk 2 meters under 30 seconds using a 4-bar linkage system and driven by the motors. The robot uses two sets of linkages front and back working together to produce a stable walking motion while maintaining efficient force transmission. The walking motion is generated using 4-bar linkages, converting rotational motion from the motor into stepping motion. To achieve effective walking, the geometry of the linkage is critical as it directly affects stability, step length, and efficiency. To achieve this, we carefully selected linkage parameters such as A, B, C, L, and leg P. First, we ensure the design satisfied Grosskopf conditions, allowing full and continuous rotation of the crank. We then considered transmission angle to maintain efficient force transfer. The foot trajectory was also designed to stay stable during the contact and lift during the motion. Finally, practical constraints like motor torque and manufacturability were considered as well. Based on our design linkages and analysis, we selected these final dimensions for the linkages. The crank length was kept relatively short to reduce the torque demand from the motor, while the coupler and the rocker lengths were adjusted to achieve a suitable step length and stable motion. The front and back linkages were designed with different proportions to ensure coordinated walking motion across the robot. Kinematic analysis, we analyzed the linkage at an input angle of 60 degrees. From this, we calculated theta 3, theta 4, beta 2, beta 3, beta 4, which helped us analyze and define the configuration of mechanism at that instant. These angles help us understand how the leg is positioned during the walking cycle. Kinematic analysis of velocities. Using an input angular velocity of 12.56 radians per second, we calculated the angular velocities of both front and back linkages. These values show how motion is transferred through the mechanism during operation. We also analyzed how these velocities change over a full rotation using the Lockton linkage system. This helps us verify that the motion remains continuous and consistent throughout the walking cycle. The robot components were designed using SolidWorks, where all the link and dimensions and joint positions were precisely defined. This allowed us to ensure proper alignment between the components and avoid interference during the motion. It also enabled accurate fabrication of linkage system based on our calculated parameters. The robot components were fabricated using 3D printing with ABS material. We assembled the system by first attaching the driving links on each side, followed by legs on each side. Both were then connected to the motor, secured using the top shell to form a complete structure. The robot was able to complete the distance in approximately 22 seconds, achieving a speed of around 0.09 seconds. It was able to walk autonomously without human assistance. However, due to the slight misassignment in the motor, the robot did not move in a straight line and instead veered to a left.